Typically when some in high school when you're so much into programming, the natural progression is that, hey, you know what, I'm already building apps.
Actually, after high school, decided to go out and study law. In the process of studying law, I got back to building apps, developed an app, which then became quite successful and one of the most sold productivity apps on the App Store.
With confidential SPL tokens that you guys have built, if there's a payroll that's happening, what does the end user receive?
So they receive confidential balance directly.
What kind of roles do you hire for? What is the expertise one needs to be able to contribute to the core protocol well?
Core protocol, it's very cryptography. The ability to also reveal things and make them public.
Engineering slash org culture you have, right? On one side, you have people coming with like tremendous amount of academic rigor. On another end, it's like, startup engineers. Very curious to, understand how do you balance these things? What does the culture look like?
It's very difficult because you can't really break things.
Hello. Welcome to another episode of the OnlyDevs Podcast. Today we have with us Yannik, the founder of Arcium. Arcium is a multi-party computation network, and they are doing probably one of the OG teams, if I may use that word, that have been working on privacy on Solana. Remember them all the way from their elusive days. So happy to have you here, Yannik. Welcome to the podcast.
Yeah, thanks for having me.
The first question we ask everyone is, how did you get into crypto? Is this your first job, or were you doing something else before?
Yeah, so I initially, actually, after high school, decided to go out and study law. And when I was a child, I taught myself how to program, but still decided to study law. And then, in the process of studying law, I got back to building apps on the side and developed an app, which then became quite successful and one of the most sold productivity apps on the App Store. And at that point, I then decided, okay, let's switch things up and maybe go back to computer science. And then I decided to, instead of studying law, study computer science and mathematics. That's where I met my co-founders. And those were really the people that got me into crypto. Before that, I had only small touching points with crypto. But meeting my co-founders, we then had this shared passion, I guess, for cryptography, privacy, and I got at that time into crypto. And then it made sense for us to apply all of those things and try to solve some of the most complex problems in distributed systems, I guess, which is how can we execute in a distributed way on fully private encrypted data.
Typically when some in high school when you're so much into programming, the natural progression is that, hey, you know what, I'm already building apps, let me go all into it. So the shift to law sounds super interesting.
I think for me, I had this feeling of, okay, I already know how to program, how to do all of those things. So I, at that point, didn't really see the need to study that because I was already programming so much. And studying computer science itself, I think, didn't give me too much knowledge because I already was developing things. But more importantly, I think what this study at university gave me was a deeper mathematical and cryptographic knowledge, which then allowed me to, again, teach myself mostly cryptography and all of those things. But I think for me, the turning point really was then switching back again, developing an application, solo developing that, and having that be a major success. And so that really drove me to want to found something bigger, to want to build something bigger. And I guess that then started this whole journey.
That's awesome. So cut to today, you're working on Arcium, right? Like, I also speaking of bigger vision, like, what is Arcium and why Arcium? Why is, like, oftentimes when people in the crypto industry speak about crypto, it's crypto the currency, but not crypto the cryptography. Whatever you described, like, kind of sounds super rooted in the whole cypherpunk ethos. Curious to hear about, like, why you are building Arcium.
Yeah, so I think why we're building Arcium, I think it's not just something that is required in crypto. I think it's required as a whole also in Web 2. And what we are solving for, and this new primitive that we are introducing to the world, is what we call encrypted computing. So being able to run arbitrary computer programs in a fully encrypted way, where all of the data that is used within those computations can remain fully encrypted. And as you hinted at earlier, one of the technological cryptographic primitives that we are utilizing is called secure multi-party computation, which, as the name suggests, already requires an element of distribution and decentralization for these cryptographic protocols to work. And so that's, I guess, one aspect in which this crypto connection comes from, because Arcium itself needs to be instantiated in the form of a distributed network, right? And secondly, these kinds of encrypted computations are incredibly valuable for on-chain applications. They are incredibly valuable for blockchains, because on top of blockchains, everything by default is public, right? And so we are introducing a primitive to these networks, and I guess right now Solana, where it becomes possible to execute anything in an encrypted way while being on top of a public distributed ledger. And so I think there's an element of a cypherpunk ethos to that, where it's important to have privacy, but I try to not think about it that way. And I think this kind of cypherpunk ethos is a fallacy that people have fallen into in the past, where privacy itself becomes a sort of political issue, only moralizing stance where you're essentially saying, hey, we need privacy, why isn't anyone adopting privacy? I think that's what people have been doing in the past, and I think that's the entirely wrong approach. The approach that we are taking is that privacy itself should be a logical business decision to adopt, and that's how this technology is going to be adopted. So our task is to empower applications and allow applications to become more powerful. And there's many aspects to that. There's the really technical and mathematical cryptographic aspect to that, but there's higher level aspects to it as well, where we need to abstract away all of those cryptographic things for the user experience and developer experience to allow applications to become more powerful, because privacy isn't anything holding them back, but instead adding new features. And so that's the way that we go about things. And that also is why we at Arcium evolved in the way that we have evolved, where initially, as you said, Jack, we were called elusive, and we're using a different set of cryptographic primitives, but then evolved into Arcium, which now allows anything to be encrypted while everything can be computed. In the meantime, what we also did, and I think that also speaks to the role of Arcium, not just enabling encrypted computations on-chain, but also for anyone to use, right? Also for traditional companies to use, is that we end of last year, acquired our largest Web 2 competitor, who have been doing encrypted computations for traditional industries like healthcare, defense, and others. And so that's the role that I see Arcium in, not in a cypherpunk role, but instead in enabling anyone, be it a business, be it an on-chain protocol, anyone to have more powerful applications, because now you can process more sensitive data.
Yeah, thank you so much for such a thoughtful answer. It kind of, it speaks to it. Anything gets only adopted if it makes business sense, and if it's only if it is a 4 delta implement over what exists, right? Versus it being because it's a virtuous thing to do. Switching gears here slightly a little bit and getting a little bit technical, you mentioned encrypted computation, right? So when you say encrypted computation, what does it really mean? Is the circuit or the function itself, is that the one that is encrypted, or is it the inputs to it that is encrypted, and the computation happens over the ciphertext? So how should people understand this.
One of the new primitives that Arcium is introducing is encrypted shared state. So when you normally execute in a smart contract environment, you operate over shared state, right? Where you have a smart contract and then there's maybe account data that is used within those smart contracts. Essentially, whenever you're submitting a transaction to a ledger, that gets becomes part of this state machine, right? So you're operating over shared state. And we are allowing for the operation over encrypted shared state. So just like within a normal smart contract environment, you can have some functions that determine how state transitions take place over this shared state. Now you can do so in an encrypted way, which means the data that is being used is encrypted. So the most simple example would be, let's say a protocol where all of us, the three of us, let's say, have some confidential encrypted token balance on chain. And then using that protocol, we, for example, can compute the average of our token holdings without revealing any of our individual token holdings. That's a computation that takes place over encrypted shared state because all of our state is encrypted and we can run a function over all of the state without anyone seeing the individual underlying state.
Fascinating. You guys also launched like confidential SPL tokens, right? So how does that work? Is it on one end there's like, for example, there is this confidential balances as a token extension in the token 22 program. So where does confidential SPL token fit in the spectrum?
Yeah, so Solana over the last few years has been developing what they call confidential transfer extensions. The confidential transfer extension for the token 22 standard, which basically allows you within your EOA to additionally have a confidential balance. And then I can send someone else who has such an account a confidential transfer, so they receive this confidential amount into their confidential balance, so publicly nobody sees the individual balances and the amounts that are being transferred. The issue with that is that simply by the technology on which all of this is based, namely ZK, zero knowledge proofs, is that it only allows EOAs to send to other EOAs. So if I have a wallet that supports that, I can send it peer-to-peer to another wallet. But I cannot, as a smart contract, as an on-chain program on Solana, utilize such a balance, which then greatly hinders the entire protocol, I guess at the end of the day, leading to the status that it's currently in where there isn't any adoption. Because anything, I cannot really do anything with my token balances, right? And so that's where confidential SPL token comes into play. It resolves all of those issues. So it allows any program on Solana to manage a confidential token balance, and then you can build very interesting applications. The most simple application that we have currently, confidential SPL token isn't live yet, but will be very soon. So the most simple example application would be a confidential payroll program, where you have some smart contract that manages a confidential payroll account where all of the salaries sit basically, and then the transfers to all of the employees is confidential. And something like this wasn't possible. In the past, you would need to control a single wallet and then send individual transfers out, but now it can sit in a multisig. It can securely sit on chain. And what all of this enables is then applications like confidential lending protocols, entire confidential DeFi applications, right? All on top of the standard. And the nice thing about how we designed the standard is that it's fully interoperable with what Solana has built. So it adds all of those missing features to what we have already baked into the chain, which is incredibly powerful. And also things like being able to send confidential transfers to anyone, which previously wasn't possible. Because if Shaq, for example, just has a normal wallet, but hasn't even considered receiving some specific token in a confidential way, I couldn't have sent him a confidential transfer. But now with the confidential SPL token, that becomes possible. I can just send him any SPL token in a confidential way. And yeah, I think the most powerful aspect to all of this really is that as a program, you can now manage those balances. So a program which previously just used, let's say, SPL token to perform some DeFi actions, can now just use confidential SPL token and send out confidential amounts and compute with confidential balances and encrypted values, which is incredibly powerful, I think.
Just to double click on that, there are two things that you mentioned that's not, that it got me very curious. You mentioned that in the confidential transfer program, since it depends on CK proofs, using it between non-EOA wallets or that is in a smart contract setting becomes hard. Curious to understand why that is actually the case. The other question is you mentioned the confidential SPL token. It need not necessarily be opt-in. How exactly does that work? Even if I haven't enabled that setting, how does it work such that the protocol can send something privately to me?
First thing with zero knowledge proofs. Zero knowledge proofs operate over what I usually call isolated secret state. So I have some secret, and zero knowledge proof then is me proving some fact about the secret by running a computation over that secret without revealing the secret. But in order to do so, what I need to have is access to the secret, and nobody else can have access to the secret, right? Which enables something like these very simple confidential transfers that Solana has built, where I know my balance, so I can generate a zero knowledge proof, submit that on chain, it gets verified, and a transfer occurs into someone else's balance. But what a smart contract cannot do is have exclusive access to a secret and generate zero knowledge proofs, right? And that's where Arcium comes into play. Where with Arcium, the smart contract can now generate zero knowledge proofs, and by being able to generate zero knowledge proofs, the smart contract can then perform those confidential transfers because of the MPC-based encrypted computing that we enable. So that's one aspect. That's the most important primitive for the system to be interoperable with the token 22 transfer extension, where a program can now manage those balances. Now, in regards to being able to send tokens to someone else who maybe hasn't opted into it, what I need to do in the standard that they've designed is I need to know your public key, but you only have a public key for encrypting a confidential transfer if you have opted in. So what we enable with Arcium is that we say you instead sort of transfer it to a program and then you can just claim it. So you don't need to generate a key up front, but instead Arcium does that for you.
With confidential SPL tokens that you guys have built, if there's a payroll that's happening, what does the end user receive? Do they receive an SPL token, or do they receive a different account that they can maybe eventually claim to a token?
So they receive a confidential balance directly. So that's important. So what they can do with that confidential balance is they can do many things. They can keep it as a confidential balance, and the nice thing again is that you can basically send that to anyone because it's already part of the Solana protocol, right? Because then it's a EOA again, so you just receive this confidential amount. Now, since we enable any program to now use this standard, you can use this confidential amount to, let's say, perform some DeFi action or pay with Solana Pay or whatever, right? You can do so in a confidential way. But what you can also do is you can, in turn, just convert it into the original SPL token, right? So you can then say, okay, I now want it to be non-confidential public USDC. So you can just turn it into that as well. Yeah.
Interesting. You mentioned I can actually use it in a DeFi application. So if I have a confidential balance, I can literally swap it on Jupyter and get a confidential token on the other side. Like,
yeah, I mean, Jupyter for that requires to support to integrate our confidential SPL token, right? But yes, you can. And the nice thing really is that again, you don't have to use anything that we've designed basically, because you just have your confidential balance. And then you transfer something in an account, and based on the amount that you have transferred, some swap is being executed. So you don't even have to use some additional cryptography and encrypt anything. So there's really no requirement for additional integrations, which makes that so powerful, because it's just something that a program now integrates. So you can transfer it to an account owned by the program, they perform a swap and transfer something back to you. So yeah, down the line, what you will see is that you receive some confidential tokens through payroll, and then you can instantly, in a confidential way, swap them. Yeah.
Fascinating thing about this is that it opens up the design space to build so many other confidential applications. Anything that we think that exists today can actually build a confidential or a private version of it, right? What are the type of applications that you're seeing that people are building, or you're personally most excited about?
Yeah, I think especially all of the DeFi primitives, really, and I think it's so powerful because the concept that you're working with as a developer is simply, I take this account balance and I don't know, multiply it by whatever fee I'm taking as DeFi protocol, right? And then I transfer that and transfer this amount without you knowing the amounts, but you can still perform this kind of arithmetic, right? And then you just call transfer like you would normally with normal SPL tokens. So dev experience wise, you don't have to understand any new concepts. And I think that's really the powerful aspect to it, and that enables developers to build these kinds of applications. So we haven't yet opened it up, confidential SPL tokens to developers. What we've built internally is a few DeFi protocols as example protocols. And for example, within a few hours, I developed an entire confidential lending protocol last week on Friday or Saturday, I think, which was a very seamless experience, just building a confidential lending protocol where, I don't know, let's say, before the confidential SPL token that we've designed, I mean, the amount of work that as a developer you would have to perform is you basically would have to start from zero and build out all of the cryptography. And by having this standard and this interoperability, as you said, it becomes so seamless, and an entirely new design space is opened up where you can say, okay, I'll take my existing application and add confidentiality. Or you can also say, okay, let's think about DeFi in an entirely new way. And what's also fascinating about this, I think, is that what you can do, and I think that's something that most people don't realize, is, let's say I now have a confidential lending protocol, and people are there's a lot of activity happening, but nobody knows how much activity is happening, right? Which again can be a downside to all of this, but that doesn't have to be the case. You can do things like, let's say every day the volume numbers are being decrypted, and so you can verifiably on-chain see how much lending has been taking place over the last 24 hours, things like that. So people can really play around with the ability to also reveal things and make them public.
Absolutely love it. When can developers start building on this? Like, how do they get started? And also, I also noticed that you guys are doing Arcium fellowships. So how can people get started? And also the audience listening to this.
Accepted all of the fellows into our fellowship program that we've done together with Super Team Earn. So over the next few months, all of those fellows will build some very exciting applications. We currently have Arcium itself on public testnet, but we will have the confidential SPL token standard live on testnet at least. So it's a very difficult thing. People listening to this podcast are developers, so they know how difficult it is to actually give precise estimates on timelines. But we are getting our stuff audited at the moment, so as soon as possible.
Are you guys, other than the fellowship, what kind of roles do you hire for? What is the expertise one needs to be able to contribute to the core protocol well?
Yeah, so for a core protocol, it's very cryptography heavy. I'm very proud of the team that I've assembled with Arcium, where we have some of the best cryptographers in the world be part of Arcium, and especially for confidential SPL token, we had to come up with some very impressive, I guess, new cryptography actually to make this work. From the outside, it looks seamless, and that's super straightforward. But actually, if you look at the cryptography, there's a lot of heavy stuff involved to get this to work. So in the core protocol, there's a lot of cryptography, but there's also, as Arcium is a decentralized network, right? There's all of those aspects as well. Arcium itself isn't a blockchain, but it's still a decentralized network. So there's all of those mechanics that need to be developed for any distributed network to work, also within Arcium, which means the node software development, which means all of the communication taking place between those nodes. And so I guess the stack that we have really is this core cryptographic stack. There's this node software, networking, scheduling, distributed computations part of the stack. But there's also things, and I think that's one of the most important aspects actually, the higher level things, like the interfaces that developers use. We have a custom Rust compiler called Arcus, which enables Rust computations to be compiled into circuits, which then can be executed cryptographically. And so those are important aspects to allow developers to build these seamless applications, because they then don't have to notice anything below. So I think the only thing that we in the core protocol don't have, because we are infrastructure, right, is extremely user-facing things where it's user UI applications, right? We have people building out those for demos, example applications, right? Games for the communities, things things like that. But for the core protocol itself, that's not part of the core protocol. Yeah.
I'm actually curious on the engineering / org culture you have, right? On one side, you have people coming with like tremendous amount of academic rigor, and on another end, it's like, startup engineers who ship fast, break things. And given that you're a cryptography startup working in this space who also has to ship fast, I'm very curious to, understand, how do you balance these things? What does the culture look like?
It's very difficult because you can't really break things. I think it's easier to ship fast and break things if you're developing, I don't know, a social media network. I don't know, what some sort of application where at the end of the day it doesn't matter too much if things break. We've started working with Web 2 customers as well in the area of encrypted machine learning, where you don't want data to get exposed, right? I think our whole thing really is the highest level of security. So I guess that's one of the main principles that we stick to. I think what you then as a startup have to look at is prioritization. I think that's what matters, because you cannot build out everything in a perfect way right from the beginning. So you basically have to pick an area where you want to find product market fit and then expand from that. And so I think we've done that, and that's also one of the reasons, I think, why we're building those things on Solana, and I guess in crypto in general, because it's an area where this need for privacy and encrypted execution is very tangible, and it's easier to work together with teams and get them to adopt this technology, whereas in traditional industries it can be tougher, and it can take longer, right? So I think that's a very conscious decision on our end as a startup, to be really, really focused on this area.
Yeah, I think the key takeaway here is that, like, have ultimate clarity in what you're doing as a business, and then everything kind of like builds around it. And especially when you're operating on some of these foundational cryptography, you can't, rigor is the way to go.
You can't really mock things. You really have to have all of the cryptography in place, and it needs to be mathematically sound and proven. That's the battle that we picked, I guess.
I have one last question. You mentioned that you're, working with some Web2 clients where, they want to do multi-party machine learning. So how does the technology work? Because this involves, machine learning, as I understand, involves a tremendous amount of matrix multiplication. So when you apply that to a setup like MPC, how do you, one, deal with so many number of multiplication? And also at the same time, like, how do you overcome the communication, basically the communication penalties?
We have a paper specifically addressing this question, I guess, which is the Manticore paper on our research section of our website. So that's basically the protocol that. So Arcium uses two core protocols, Cerberus and Manticore. Cerberus really is that which powers the Arcium network and confidential SPL token and all of those things. And Manticore is tailored for AI applications. And so the points that you've mentioned are exactly all of the points that this protocol addresses. And the team that we've acquired had developed this protocol for more than 8 years and done all of the required, I guess, cryptographic MPC research to get that into fruition. What's so powerful about it is that machine learning itself, I guess, has two aspects, right? It's the training aspect, which requires all of those operations, and then the inference aspect. But I think where it becomes really complicated if we look at LLMs, for example, right, where there's even many orders of magnitude more operations involved. What we were able to run earlier this year was, for example, an inference using the 16 billion parameter model of DeepSeek within MPC in a fully encrypted way. And so the question that you always have to ask yourself, I guess, when running these computations is, if you have public model weights, it becomes cheaper. If the model weights are encrypted and the prompt, I guess, is encrypted, that then becomes very difficult to scale. But if one of those is public, it becomes easier. And for machine learning, I think the important aspect that Manticore is addressing is that it's in a very smart way solving the real number arithmetic problem, because usually you would operate over finite field elements, and with Manticore there's basically a fixed point fixed point arithmetic. Whereas it basically at compile time of the circuit identifies the best point fixture based on floating point values. So all of the details of these protocols sort of go over my head. I'm unfortunately not as good a cryptographer as all of the team members that I have. But I think what all of those AI applications really are for me is a testament to how powerful the technology really can be. We, especially when doing machine learning operations, have seen that the runtime is very good, and I guess it always depends on It depends on the type of data sets that you're evaluating. So in the Web2 application that we have, it is medical data, for example, where it's basically scans, and the technology had also been used, Manticore had also been used for 3D lung scans, as far as I know, in the past. So at the end of the day, what I'm trying to say is that matrix multiplication over a real number, so tensor operations, is specifically what this protocol is fine-tuned for, which is something that with Cerberus, for example, would be quite difficult to do. So with Cerberus, it would be way more difficult and basically impractical to run these computations. That's why Cerberus as a protocol really is fine-tuned for those on-chain operations, and Manticore really is fine-tuned for those AI applications. And yeah, both of those together, I guess, form Arcium. But what you don't need for Manticore, for example, is a Rust interface. You don't need to program something with Arcis, because that's not what machine learning engineers do. Instead, we have a Python interface where you can just use pandas and TensorFlow interfaces to specify the training and inference workflows.
Oh, that's awesome. It also brings us to the end of the podcast. Thank you so much for joining us, Yannik. Like after this podcast, like I'm so pumped about Arcium when it goes on mainnet. And I would also personally like to get my hands dirty and build something on top of Arcium.
Yeah, thank you very much.
Thank you for joining us.
Thanks for having me.
Bye-bye.